Hi, my name is Courtney. In this problem, we're told that the population in millions of a country in 2019 and the expected continuous annual rate of change K of the population are given as shown over here. We are asked to do a few things with that information. So first, we want to find the exponential growth model for the population, and we're given a clue to let t equal 9 correspond to the year 2019. So let's start by looking for that exponential growth model for the country of Paraguay, where we're told that the 2019 population is 7.1 million, and we're given the K value, which is telling us the rate of growth of 0.012. So how do we take this information and begin to find our growth model? Well, the first thing to make sure that we recognize is that this 2019 population corresponds, as we were told, to when t equals 9. And so we can look at this information about the 2019 population, and if it's helpful, we can express this as the population at t equals 9 equals 7.1. So let's take now all the information we know and plug into our exponential growth model to see what information we have. Well, we know the value p at t equals 9 is 7.1. So plugging into p equals CE to the KT. I have my value of p over here. That will equal 7.1. What I don't know is the initial population of Paraguay, so I don't yet know the C value. But I do know that it's an exponential growth, so I'll be multiplying by the natural number e raised to the k times t power. We know k, the growth rate, is 0.012. And remember that this population of 7.1 million referred to a t value of 9 as given in our problem. So we also have the value of t here, which will equal 9. So we've been able to take the information that we were given, plug into our exponential growth model, and all we have left to do in order to be able to have an equation that will model this growth is to be able to solve this equation for C. In order to do that, C is currently multiplying by e raised to the 0.012 times 9 power. So if I want to isolate C, the initial value, I can divide both sides of my equation. And in doing that, I will find that C equals 7.1 divided by e to the 0.012 times 9. So now, if we want to see what this value is, we can do some plugging and chugging on a calculator. This will be 6.373 approximately. So this is our initial value, or our C value, which allows us to go back to this exponential growth model and to write an equation that will model the growth of Paraguay at any year that we want to know it. That equation will equal P equals our value C. In this case, we found it was 6.373 times E to the K, which remember we were given was 0.012, times T power. This is our exponential growth model that will allow us for any year to determine what the population in millions of Paraguay would equal in that particular year. So now let's take this information and continue on with question B. B asks us to now use the model that we found in part A to predict the population in the year 2040. So how do we do that? Well, we have this model that allows us to predict the population in any year that we're given. The only thing we have to be careful about is to interpret this year 2040 Remember, we knew that t equals 9 corresponded to 2019. And so what that tells us is that t is really telling us the number of years since 2010. Right? Because 2019 was t equals 9. And so fast forwarding that to 2040, if we want to know what is the t value, be careful. It's not just going to be that t equals 2040. If we use that, we're going to get a much larger population than we want to here. In our case of 2040, that would mean then that t, it's 30 years since 2010, so 2040 would correspond to a value of t equals 30. So perhaps the hardest part of this problem is making sure that we identify the correct value for t. Now that we have it, we've done all the hard work in part A. We just substitute into our growth model. The population P will equal 6.373 times e to the 0.012 times t, in our case, 30. At this point, we can again enter this information into a calculator to get an approximation for the population. And when we do that, we find that the population is approximately 9.13. Now we want to be careful. We're interpreting a population here. Remember, the population is in millions, and so that means that a good prediction for the population in 2040 would be 9.13 million people. Finally, then, we're ready to look at part C of the problem. And part C asks us to discuss the relationship between the sign of k, which told us our rate of growth or decay, and the change in population for the country. So what we know is that k, the value that we were given here, was positive. The sign of k is positive, and what we have learned is that for any exponential growth model, if k is positive, we have actually exponential growth, whereas if k had been negative, this would have been exponential decay, meaning the population would actually be decreasing over time. But here, our positive value of k, means that over time, the population grows. It increases. And in fact, we can see that that's exactly what happened when we look at the population in 2019 of 7.1 million versus the population in 2040 of 9.13 million. So that growth is exactly what we would have expected given that this k value was positive. Great job persevering through this problem. Now you're ready to get some more practice on your own.